Hi everyone, let's proceed further to discuss on microservices design patterns. So while building an application, there can be two types of the application, greenfield or brownfield. In case of greenfield, you are actually developing a software product from the scratch rather than building from an existing application, but it requires a minimum operational readiness and technology readiness. You need to understand the tech stack. Say you're developing a microservices from the scratch, so you can do a lot of analysis around it, but you need a minimum level of operational readiness. But with the brownfield applications, it's a kind of upgrade or redeveloping an existing application. You have a legacy code, say instance you want to convert the monolith to the microservices. So that's an example of brownfield, though it is a slow change, but it is more reliable and scalable. And you do have some basic infrastructure, so it can be cheaper approach while going with brownfield application. Microservices design pattern. First is your decomposition pattern. Say you want to decompose on the basis of business capability. So consider you have an e-commerce app and you're creating the separate services for products, customers, order, payment. So you can decompose on the basis of business capability. In case of decomposition on the basis of domain and subdomain, you actually use a domain-driven design model wherein you can break that model to subdomains and each having its own scope or the bounded context. This can be useful if you're building an application from the scratch. You can use either of them. But in case of Strangler pattern, you have two applications which are living side by side in the same URI and they take one domain at a time. So your new refactored code, refactored application will actually replace until you shut down the previous one. So this can be useful when you're converting monolith to the microservice and you want both of them to be live side by side until you shut down the previous one. For communication between the services, we have like point-to-point communication pattern wherein you communicate between the services. But this becomes difficult in case of the dynamic communication. So here you have this cross-cutting pattern wherein the services communicate through the service discovery. So service discovery, since the service instances are constantly created and destroyed, so the location changes, right? So so you have this service discovery which gives you a key component service registry. It actually contains the currently available instance of each service with their connection details. So you have client side wherein your service will query the service registry to retrieve the details from the required microservice and then connect to them using the load balancing algorithm. So it will query the service registry. But in case of server side, your client will contact the load balancer making a request, and load balancer will consult the service registry selecting the optimal service and it will route the request. Right here you have a load balancer which is actually consulting the service registry. Example is your AWS ELB. For external communication we have API gateway pattern. So your gateway acts as entry point to forward the client request to the appropriate microservice. So with the help of this load balancer, the load of the request is sent to the respective services. So example, you can use Netflix, Yol, RPG. So you have your throttling and some authorization policies you can define at the gateway level. But make sure we don't put any business logic on the gateway level. So to implement security to our microservice design, we can use LDAP or access token. And access token implementation can use JWT tokens or OAuth 2 protocol. So OAuth, there's a separate flow wherein your OAuth server verifies the client and it returns back the access token. We can have a separate session on that. Through certificates, we can implement security and multi-factor authentication. So in multi-factor authentication, it secures the application and it blocks the malicious user and warns them whenever any intrusion occurs. Next is the data patterns. So we can have database per service, wherein each microservice will have a dedicated database, which means that it can have a private table or a schema dedicated to that service, right? Next, it can have a shared database per service pattern, wherein more than one database per service can be aligned, and it resolves the issue of denormalization. Saga pattern is basically for maintaining the data consistency in a distributed transactions world, wherein you can implement, say, Saga through orchestration. So orchestration is wherein the you have an orchestrator. So orchestrator calls it calls the service A, it waits for a response, and then it will call the service B, and so on. So your orchestrator is actually deciding the action, and it becomes a single point of the failure. And the calls are often synchronous in nature in case of orchestration. And choreography is wherein each service will produce and listen to another service's events and decides the action. And it's more flexible and scalable than orchestration, and it is asynchronous and non-blocking. So it depends upon the architecture, so which Saga pattern you want to implement. Then for API composition is when you are implementing the queries, and that involves data from multiple services, right? So then we can use API composition pattern, or another alternative is CQRS, command query responsibility segregation, wherein it breaks the application to command side and server side. So your command side will handle the requests which are related to your create, update, or delete, such kind of queries, and query side will take care of the materialized view, right? And aggregator pattern is another pattern wherein how the data of multiple microservices will join, and a particular response is sent as a whole, right? So in that case you can use aggregator pattern, and it's based upon the drive principle. Do not repeat yourself. Circuit breaker pattern, it provides you reliability and fault tolerance mechanism whenever the microservices are down. Example, Netflix hysterics. It gives you the fallback mechanism which will be executed whenever the services are down. So you can configure that hysterics behavior in the methods, wherein you need to implement the circuit behavior, or you can implement the custom circuit breaker. Then for monitoring and to help to address the observability, we can use a monitoring tool to capture the application metrics and monitoring, as in ELK and Kibana can be, etc. can be used. Then for log aggregation, to aggregate the log from the service request, the tools like Splunk, Sumo Logic, etc. can be used. For capturing the health check of the services, Spring Boot Actuator can be one of the example. Then for distributed tracing, we can it is wherein it will track and observe the service request as they will flow through the distributed system, as they will collect the data as the request goes from one service to the another. So you can assign each request unique request ID. You can pass it and include the external request, right? It will record the information. So for distributed tracing, we can use Spring Cloud Sleuth along with the Zipkin server. Then for deployment patterns, we can use service per container. Say in a microservices world, you have the services which are packaged as a Docker image, and then you can deploy them on the servers like AWS, EC2, Kubernetes, or OpenShift. Then service on deployment platforms, platform like PaaS services like Cloud Foundry, or serverless services like AWS Lambda can be used. Then green deployment strategy is to reduce the downtime or remove the downtime, right? Software downtime. So you have two production environments like blue and green, and at a time one would be active. So these are the examples of deployment patterns. So quick glimpse of some useful resources which you can go through. So thanks for watching my video. Don't forget to like, share and subscribe to my channel for more videos. Thanks.